Hi everybody, my name is Botswana, so let's get started. So let's say you're in a computer laboratory, okay? So, and then you do reading in the glassware. When you say glassware, it means like it could be beverage, it could be conical flask, in all those type of the glassware, which give you accurate reading, okay? So now when you read, okay, excuse me, sorry. When you read this, how you gonna mark? Because sometimes you see here in the eyes, let me show you something here. Like, let's say this is a student here, okay? So it's reading. Okay, here's a student here, just a second. See how I read, see? So now what you do, for the most cases, whatever reading you have, like for example, let's say this is a glassware, like conical flask. Let's say it's 31.0, so it's going to be 31.0. And what you do all the time, make sure you plus or minus. So you must say plus or minus what? Your plus or minus, you see, it's always, you say, see here, 0.5, 0.5, but is milliliter, milliliter. If it's for the glassware, like conical flask, whatever, like you see, that's why we say you plus or minus. See, so for this case, yeah, let's say for 42.2 is going to be 42.5. You plus or minus, and this is 0.5 bracket milliliter. You know why we do that? Because it always gonna be uncertainty or some errors. See, slight. That's why you have to plus or minus 0.5. So same with the thermometer. You see, but for the second case, this is thermometer. Let's say you measure the room temperature. You go to the laboratory, computer laboratory, and they let's say, check whichever chemical you have. Put in a glassware, let's say conical flask or test tube. Okay, measure the temperature. You see. So for the most cases, whichever temperature you have, for example, for this case, this is thermometer, remember. Thermometer, we use it to measure the temperature of, it could be any chemical compound. So now it's going to be 11.0, excuse me, 11.0, and then we plus or minus what? 0.5. And then remember, you must say what? This is degree Celsius. See, because I say unit for temperature. Okay, so now that's not part of the question. Now let's go to the question here. So we got a question here. They say instead, let's say you do your experiment, you're done. So now you have this question, okay? Because I'm answering this question because it comes from one of the students, okay? One of the students, okay? Okay. So they say, what is the unit? What is the basic unit of metric system for each of the following? So the unit of length is meter. So the unit of length is meter. See meter here. By the abbreviation, you represent using what? M. That's the unit of length. Now, what about the mass? Mass for metric system. Remember, this is a metric system. Like let's say in a computer lab. So the mass is going to be in gram. I don't think somebody's going to say, "Oh, now measure 2 kilograms of sodium sulfate." No. For the most cases, you're going to have a little scale. You know, we call it sometimes balance. You see. The balance that you can weigh. You can weigh, let's say, mass of sodium chloride or mass of any salt, which you can do in a computer lab. Excuse me, salt. My apologies, sorry. So I'm saying, so it's gram. So for mass, it's going to be gram, and the abbreviation of gram is G. Okay. Now for volume, see, remember these are unit metric system for the following. Okay. For volume is going to be milliliter. So either you can say liter or milliliter, so you can put them both. For me, I'll just say both. I'll say liter, which represent using abbreviation L, and then I can say or milliliter. Make sure you write them both. Milliliter, which represent using ML. See, now let's go to the next. So temperature, we know is degree Celsius. Degree Celsius. Temperature, degree Celsius, and 0C. Okay, so the first question is done already. Now let's go to the second question. See, let's go to the second question. So for the second question, they say state the common laboratory instrument, and then which is going to measure each of the following. Okay. How are you going to measure mass of a sample? Mass of sample, for example, somebody say, oh, you have a sodium chloride, for example. Or let's say sodium carbonate. See what I'm saying? Or they say you have a calcium carbonate. This is sodium carbonate or sodium sulfate. Okay, let's assume it's sodium sulfate. Let's say sodium sulfate. Let's say you got sodium and sulfate. Right, it has a 2 here. Sodium sulfate is a small 2 here. So I'm saying, so these are sample. For example, these are sample mass. Let's say, okay, take your sodium sulfate 30 gram or 5 grams. So this is sample. Means we don't take the whole sodium sulfate. We just take a little sample. You see, but that's not part of the question. I'm trying to explain to you what do they mean when they say sample. So mass state the common laboratory instrument, means the instrument that we're going to use to measure each of the following. Mass of a sample. So mass of a sample, how do you measure mass? Using what? You use what? Balance or scale. Balance or scale. So we can use balances or scale. See, balances or scale. Okay, now let's go to the next one. I'm going to put all the answer here, don't worry about it. Okay, the next one is going to be how you measure volume of water. Volume of water you measure using what? Graduated cylinder. Okay, you use what? Graduated cylinder. So you say graduated cylinder. Graduated cylinder. Oh my god, okay, my handwriting is dirty. Okay, graduated cylinder, mass, graduate. Also, another one you can use what? Volumetric flask. Let me write here volumetric. So still continue the same thing, right? You can write volumetric flask. Another thing we can use pipette. So you can write very small in example. So you can use 3 things. Okay, there's more, but let's say graduated cylinder, volumetric flask, and pipette. So these are some of the instruments that we can use. But if you have to pick one, how could I say graduated cylinder? You understand? But I write all them 3. Okay. Now let's go to the next one. So the next one, they say temperature of air. Oh, this is thermometer. Thermometer. I think this is thermometer. Thermometer. Excuse me. So we're done with it. Excuse me, sorry. So we're done. We go to question number 3. Question number 3 is easy. They say start the metric units associated with each of the following. Oh, so if we have a balance, what is that metric unit we have? Oh, it means we're gonna have to measure some weight or mass of a weight. So this for this case means this is a gram, because mass is always in gram. So you say, oh, so the metric unit is going to be gram for mass. They talk about balance, because balance, what do you weight? Balance or scale. You put something on a balance or scale. When you say balance, scale is the same thing. So what is that? Which unit you're going to weight there? It's going to be gram. Gram, and the abbreviation is small g. Okay. Graduated cylinder. Oh, this you know is the volume. But which unit is the volume? Milliliter. So it's going to be milliliter. Milli. And the abbreviation is ml. Write everything is at the heart. Right. Okay. Thermometer. You know it's going to be degrees Celsius, because thermometer is for temperature, but the unity, because they say here, they said the metric unit. It's going to be degree what? Celsius. Be space here between degrees Celsius. Okay, so we're done with it. Now let's go to the next question. So for the next question, I want to show you something here very, very crucial. They say here, okay, question number 4. Select the measurement that is consistent with the uncertainty of each of the instrument. Okay, so if we measure the milligram, so what is the milligram means? We can use means we measure what day? Okay, milligram balance. Okay, so with me, just a second for me. Just a second, right? Sorry, sir. Okay, sorry. So now they say milligram. So gram. See, so we want to know, okay, when you measure gram in a scale, does it show 2 numbers or 1 number? Like, does it show like a watch? Does it read like a watch? Like, for example, let's say 31.6, or does it say 31.60, or does it say, let's say for example 31.600? Which one is correct? That's how they ask. See, if it's on a scale, means it's going to be as a gram because it's on a scale. So now we want to pick and see which is more accurate. So the accurate one for on a scale, which is going to show, of course, going to be this, the last one in the scale. You see, that's going to be accurate in my opinion. See, but also look at the scale. How many number does show? One of my guys told me like, no, it must be the second one. So see, look at your scale and see what I'm saying. But I mean, I'm going to pick the last one. I'll say the last one, which is going to be 5.00 gram 000. But I have a doubt. Please, you can verify with me about this, right? I don't know why I have a doubt. I think the second one, I think so. But look at your scale or your balance. If you have the computer lab, just look at it, okay? So it could be the second one or the third one, but I'll pick the third one, but I think it's the second one. So look at your scale, okay? So the first one is done, and then you can verify with it if which one is correct. Say, oh, you know what, Mutwana, you was wrong. The second one which is right, or the third one. But I'll go for the third one. Now, let's go for number B. So graduated cylinder, we know that's going to be volume. So for volume, if you look at the cylinder, let me show you for example. This is cylinder here. What is cylinder? Okay, check out cylinder here. Graduated cylinder, this example. How does it read? Look, it's like, look, 31.0. Can you see only one decimal and a number? No double zero, no, or triple zero, no. You just say, if it's 5, it's going to be 5.0. You see what I'm saying? And they say milliliter, for example. So you can see here, they say 42.5 milliliter. So it doesn't have like a 2 decimal place. Same with the temperature also, you see, one number after decimal. So if you come back here, excuse me, Apollo. Over the question now. Yeah, this one right here. Okay. So if you come here careful. Sorry, Femi. So if you can look careful here for graduated cylinder, means it's going to be the second one. The second one is correct, which is what? 5.0, because there's no double, there's no, it must be one decimal, just like I show you. So this is going to be milliliter is correct, okay? Now we go for C. So for C, the thermometer also the same thing is going to be the second one also. It always thermometer, let's say 31.0. It doesn't have it like 00 or whatever, no, only one decimal place. But the first one you can verify, okay? You can have a look and then you can verify, okay? So we're done with there. Now we go to the next one, okay? But now, so now what I'm gonna do, I'm gonna give an answer for the answer for phase 1 to number 4. So these are answer here. Also, I'm gonna attach under the link below, and then you can simply download. So these are answers here. You can see here, I put everything together, saying, oh, the length is meter, the mass is gram, the volume is in liter, temperature degrees Celsius. Means the answer of that what I was doing, okay? Mass of a sample, we use what? Balancing scale. The volume, we use what? Graduated cylinder or volumetric flask or pipette or burette. You see what I'm saying? All this stuff, you use them. All this we call them glassware, not stuff. I need to have a chemical to works. All the glassware, we use them to measure the volume of a water. Now, but for the most case, use the graduated cylinder and volumetric flask. You can skip the last one. If it's 2 or 1, just take the first one. Temperature for air, thermometer. So we're done with it, just like I said. Now, balance, we say what? Balance, we use what? Mass in the graduated cylinder. It measure what? Millimeter. They say state the metric units associated with each of the following instruments. It means I'm repeating what I was saying, but I wrote the answer now. So what you could do, you can just simply copy, write down, copy the answer. See, so that's the answer right there for what we just did. Now let's go to the next question now. Your next question, question 5. So question 5, they say here, state the uncertain, state what the uncertain for the following. You see here they say plus or minus 0.5 of the following. So we want to start with the mass. Can you see? That's why I was saying the first question, it must be 3. For mass, it must be, see, 25.000 grams. So for the mass, it must be 3 decimal. You see, that's why I was thinking. You see, they even give it to us. Look at it, excuse me. Can you see this one? Whenever there's a mass, there's a 3 number. Can you see this is the 3 number? That's why I was thinking this. It's just my opinion. I could be wrong. Okay, that's why I think this is correct for me. But so you can check your scale. I think this is correct. I think so. Okay. Now let's come here. So now we want to write it. Okay, but using what? Uncertainty. So you have 25.000. So we're gonna add or plus. We're gonna add or plus what? It's gonna be what? 0.5. Can you see 0.5? But it must be in the same format. So it's gonna be 0.5, and then it must be how many zero here? 1, 2, 3. After decimal, 3 number means there's 1 number at 200. So means here is gonna be 3 number after decimal, 3 number after decimal. And it did not change any meaning because it's still 0.5. You understand what I'm saying? So it's in the same format. But remember, this is a gram, so you put your bracket, then you write your gram. Should I say again? You got it. Let me say one more time, okay? Means this is 25, so write your 25. But how many zero? 1, 2, 3. So now remember, you must plus or minus here about answer 10. But this is 0.5. So come here, compare the number of decimal. After decimal, how many zero? 3. After decimal, how many zero? How many steps? 1. So must add 2. So it become like after decimal 3. After decimal 3. You see what I'm saying? And you can see it did not change any meaning because still 0.5. So remember, the first one is a gram, so put gram. So this is the same mistake. I will just redo it. Okay. Now let's go for the next one. So for the second one is what is just simply temperature. So temperature, we're going to say 25.0, and then no plus or minus. But for temperature, we don't put a lot of decimal, only 1 number. So it's going to be 0.5. Can you see? After decimal, just a 0 here, and after decimal, it's only 1 number. Meaning 1 number, 1 number. Okay, this is Celsius, so it's Celsius degree. So we're done with question number 5. We go to question number 6. They say state the number of significant digit. Okay. So to know the significant digit is very, very easy. Let's start with the first one. So for the first one, you say, oh. So what you do, look, you go after your decimal. Let's say somebody give 3.05. How many significant unit here? There are 3. See what I'm saying? Because this is significant unity. This because even though it's in the middle, you must account all of them. But so there are 3 significant units for this case. But if somebody gives 0.800, how many significant unit here? The significant unit here, you ignore these, they going to be how many of them? 1, 2, 3. So I'm saying those are significant unit. But if it was like this, let's say let me say just a second. Let's say, yeah, let's say somebody give you 0.0003. How many significant units? Is only 1. You know why? Because look, you don't account anything here if it's on the left. So only 1 significant unit. Now let's go and answer this question. So the first one, how many significant units here? There are 3. Because like we say, see there's a decimal, so this is like 500. So you're going to say means 5 and 0 and 0. Those are significant unit. So we're going to say the first one is going to be 3 significant unit. Now let's go for the second one. So for the second one, it's going to be only 1 significant unit. Because look, just like I'll say on the previous one. Okay, let me do this. So this is going to be 3. Here it's going to be 1 because remember on the left means you're going to involve this. So it's going to be only 5. 1 significant unit. Now 50. So for 50, this is 3 because the number is on the left. So it kind of countable. So it means you have 5, 0, and 0. So it's going to be 3 significant unit. Number 4 is going to be 2 significant units because everything you must account here, 5 and 5. So 2 significant unit. Number E, see, first one, second, third means all of them is going to be accountable. So it's going to be 3 significant unit. And then now we go to the last one. It's going to be only 1 because these zeros on the left. So ignore it. So just say 1 significant unit. Don't want negative. It's not going to affect our significant unit. Now we're done with it. Now we go to the next question. So next question here is very interesting. So they say here, perform the indicated math operation, and then our final answer now, they say round off the answer to the proper significant digit. In other way, they say, okay, when they say proper means do like the whole number, and then give the final answer is the whole number. So in other way, I want to show you an easy way. Okay, so what we're going to do, multiply this number only. 5.15, 2.25 times 1. When you multiply all the three, you're going to get 11, 5, 8, 7. So this centimeter means it's going to be centimeter cube. Okay, and another thing here is going to be decimal here. Remember, when you multiply all them decimal, forgot it, there must be decimal here. Multiply all them, is going to get this 11.587. But so now that has not yet been rounded off. They say as a proper significant. What is a proper? Proper is like the whole number. So meaning I'm going to come here. As a proper means we only take the, we don't need decimal. So remember this is more than 5, so it's going to change it. It's going to become what? 12. You see what I'm saying? Because if you approximate this, so you take only the whole number. If they say just a proper significant digit, means you only take the word. For example, if somebody got, let's say 9.123, okay, it's a proper significant unit. It means you don't need this decimal. It means this is your answer here, but you must look at this number. Can one change 9? No, it cannot, because it's less than 5. But if this number was, let's say 7, excuse me, before we change, okay, if this number is 1, our significant unit is equal to 9. But let's say this is 7. If that's 7, and let's say change as the whole, as a proper significant unit. So for that case, if it's a proper, meaning, remember, this is the proper. So this 7 is going to come, it's going to be 10, because you approximate. So as a proper, it's like they don't need any decimal. That's what they mean when they say proper. So for this case now, so this is going to become what? 12, because you don't need all this. But remember, this number is more than 5, or 5 itself. So it's going to make this become 12. Now let's go to the next question. So answer is going to be what? 12. Now if you go to next question, now you do play the same game. So divide now. This centimeter square centimeter cube means you remove 2 centimeter, remove 2 centimeter. So you're going to let you the centimeter. And now take 15.15 divided by 12. When you divide that, it's going to give you 1.2625. See, but remember they say you have to round off as the proper significant. Means we don't need decimal, so means you only take these. But I can 2 change 1? No. So the answer is going to be equal to 1 centimeter. But so the answer is 1 centimeter. I'm going to put the answer here that you can see all the answer clear. See, but let's assume it was, let's say 1.872. See, this one is going to be another story, because as a proper significant means you don't need decimal, means you need this, but you must look at this number. Is this 5 or more than 5? Oh yes, it's more than 5. So it's just going to be 2, but for this case this number is less than 5. So that's how you change it. Okay, so final answer for this one here is going to be equal to 1. Now let's go to the next question, then question number 8. Okay, so question number 8 here, they say question number 8, they say explain why you round off the number in a calculator. Okay, like look, let's say you put in a calculator and they get 6, 8 point, I'm just saying. So why do we round off? So I'm saying we do round off this because calculator sometimes it give us more digits. It give us what? More digits. So we usually do that because the calculator often give us more digits than the number significant figure. See, which is allowed in the answer. Like let's say you put your calculator, the answer, like previous question, you see, we put in the calculator, the answer was very long. So the calculator gave us very long, but now we have to approximate the number because calculator does not give us as a significant, as a proper, or any significant unit. So we have to do approximation so that the answer can be what? In a significant figure, because you see, because the calculator often give more digits than the number significant figure allowed in the answer. That's what we have to approximate. So I'm gonna put up here the answer so you can see, and you should not stress like, oh, you raise when it's lighter faster. So that's our answer right there. You can simply check the decimal here, excuse me. See, like you see, that's how we approximate. Because the calculator most of the time it gives us a longer answer, which is not written as a significant digit, which is allowed. Okay. Okay, so I have written there. You can simply read the same thing I said is what I wrote here. Okay, also like I say, if you need any document of hard copy, you can let me know, or you can follow my social media, and then I can send you as a hard copy, or you can write down. Okay, now we're done with that. Now we come to this question here. So this question here, of course, number 7 we did already. Okay, number 8, yeah, we did already. The same thing. Why do you round off a number? Calculate, display, additional, subtraction, multiplication, division on a calculator. Okay, this one we did. Now let's go to question number 9. So they say here, what glassware? Remember, when you talk about the glassware, means you talk about the volumetric flask, pipette, burette, volumetric flask, and all those test tube. All those are what are glassware. Okay, those are glassware. So what we're going to do, those are glassware. So now what we're going to do now, so they say now, what glassware would you use in the laboratory today for the most accurate for measuring a certain volume? Oh, so we have a lot of glassware, but which one is more accurate to measure the with the volume? So we say the one which is most accurate is volumetric pipette. It's volumetric pipette. And then another one is gonna be burette. And another one is volumetric flask. The last one is called a volumetric flask. So this is the most accurate one. Volumetric pipette, burette. Oh, this burette must have a double R. Let me write well. And then burette. And volumetric flask. Okay, so we're done with it. Now let's go to the question here. Like I said, I'm going to come and attach the solution here. Let's go to the question quick. So we solve it. So the last question is actually easy. So now they say here, how would you make 10-liter solution of? Oh, so we have what? 10 liter of nitric acid. Oh, so this is a volume. So we have what? Volume. Let's call volume 1. We got equal to 10 liter. And then this is because they say how would you make this volume? So we have a molarity and volume, because when they say 1 mole means, or we have a molarity. If this is volume of what of? Look, how would you make this volume of nitric? Mean the same volume. If this V1, this can be molarity 1, which is equal to 1 mole, capital M here, so 1 M. From, oh, so there's another mole. So let's call this M2. Let's begin with separate. M2, 7 mole. So now it seems like we got V1, M1, and we have M2, but we don't have what? We don't have a V2. That's what they're looking for here. So we got a very little formula here. The small formula say, okay, right here, M1 molarity 1 times volume 1 equal to molarity 2 times volume 2. So we want to get V2 here. If I can look careful, do you have M1 molarity 1? Yes, we have, which is what? 1 mole, 1 times volume 1. Do you have volume 1? Oh yes, we have is 10 liter equal to. Do you have a molarity 2? Oh yes, we do have is 7 multiply volume 2 we don't have, okay, 7, excuse me. So this 7 m2, 7 what mole times means this mole is unit of the or even if you, I don't have to write, it's fine, I don't have to write 7 times V2. So I want to get the value of, okay, no, very good, it's 7 here. So I want to get the value of V2. Now we did this 4th grade, means I'm going to divide by 7 throughout. Divided by 7, divided by 7. So finally, this is going to cancel. Excuse me, sorry. So V2 equal to, take that, plug in the calculator, I'm going to get to 1 point, means you take 1 times 10 over 7. This is going to give us 1.429 liter. See? So now how would you make 10 liter? How would you make what? 10 liter of molarity of 1 from 7 liter? Means you need to have a volume of 1.42 what? Liter for you to do that process. You see? And yeah, we're done with that. So now the answer, like I say, every time when I finish, I write all the answers clear. See that you can follow. Like I say, this one we're done already. On the previous, and this answer here, you can write very slow. Now, but are we done yet? There's something to mention here. Oh, my apologies. Sorry. Man, it's late night right now. I'm doing this video. It's almost 3. Okay, 3 a.m. Now, they're not finished. They continue saying, excuse me, they continue saying the question was not finished. Also, they say describe what glassware. So we know glassware, right? So the type of glassware we can use when you do this nitric acid. If you want to make nitric acid formless, which is nitric acid is 1 mole, like they say. I know 10 mole. No, nitric acid of what? 10 volume, 10 liter, and 1 molarity, which come from the 7 molarity of another solution. So they say which glass are we going to use? So you think which glass are we going to use? Of course we know volumetric flask. That's how we're going to use. We're going to say the glassware is going to be beaker, or I'll say burette, and then volumetric flask. Also beaker. Also, yeah, those are some. So there's a burette, volumetric flask, and beaker for you to do the process. But there's a little more. Another one that we can use, retort. It's called retort. I don't know how to pronounce it, but it's written like this. Retort. That's another one. See? And then another thing that we can use, we might need, yeah, these are some. You see, those are some. These are some. See what I'm saying? So these are some of the glassware that we can use. Glassware. Okay? And this is the answer here. So this is the answer here. Oh no, it's not that one. Sorry. Yeah. No. So where is it? Let's do this. No problem. I hope you can see. Okay, so this is our calculation here. I just click play so you can see. This one we did already, right? That was 7, 8, and 9. Okay, so you see exactly here I say, but I don't think we need Bunsen burner. We don't need Bunsen burner. It's just a tripod stand and all these things. Okay, we don't need Bunsen burner. You know, there's no proof that we need Bunsen burner. Okay, so that one we done already. So you can just say we need what? The glass we use is beaker, burette, volumetric flask. Another one is what? Glass retort. and then 3 10. Okay, so those are some. So the last part we need to know these ones. These are very, very important. When you do the laboratory, these are hazard signboard and the definition. This is very explosive. Whenever you see this sign, meaning is this chemical or whichever solution you want to touch or doing experiment is very explosive. It can explode. Okay, see, and a good example like organic peroxide. Organic peroxide, they're very explosive. You see, yeah. So when, let's say, you deal with a let's say organic compound like petrol, you see, it can explode. So you need to know the sign. So you read the sign before you use, or when you use, so you are aware of. This second one is inflammable. Inflammable means it can catch fire very quick. So they say these example are gases, aerosol, liquid, fluid, and see, and self-heating substance. See, so these are very flammable. Corrosive means they can corrode your skin, or it can burn your stuff, or it can get to your eye. Those are corrosive, and this is sign. So know the sign and what the type. Okay, this look like that, but it's not the same look. So this oxidizer. See, this oxidizer. And the last one here is what? Compressed gas. And yeah, you can just memorize that one. Also, there's another one here at the end. And this is a toxic substance. And you say this is accurate toxic substance. And maybe fatal or toxic if it's inhaled. If it's when you don't go to the chemist laboratory, then you want to inhale everything, like you're gonna be trouble. Okay, and this is very irritants like this one right here, and then this is hazard, and then environmental hazard. See, and another things, look, you might be new right here. Okay, so if you FaceTime in my program, make sure you come and subscribe to this platform and see, you can see what we do for the community. Go subscribe to Mchwana Nkosi. Mchwana Nkosi is the program where I feed homeless people in need, you know, especially vulnerable people, so they can stand on their own 2 feet. You see what I'm saying? Because sometimes you might think, let's say you do little, if you can do something for your community as well, please do it. Let's change and help the vulnerable people. Sharing is caring. You don't have to be billionaire or trillionaire for you to share with the people. You can just simply have an average, and you can share with the people, and they can have a little. See, don't afraid to give a share, because that's not gonna make you poor. Okay, just a little things, And also you can subscribe to this platform, Chwana Band Academy. And thanks a lot for your time. And you know what? I'ma see you very, very soon, and I appreciate. I'll see you.